So now I've got two complex numbers and I want to divide them. I have 3 plus 5i as my numerator and 4 minus 6i as my denominator. And this feels very wrong to me. And it feels wrong to me because I have an irrational number in my denominator, which is not a good thing for math. So I'd really like to get rid of this complex number that's sitting in my denominator right now. We're going to do something called rationalizing the denominator. We want to turn this into a rational number. Rational is good. So how do I get rid of a complex number? I use something called the complex conjugate. The complex conjugate of any complex number is calculated this way. If I have the imaginary, or the complex number 3 plus 11i, its complex conjugate is 3 minus 11i. Let's do another one of those. If I have the complex number 2 plus 6i, its complex conjugate is 2 minus 6i. Do you notice the pattern? A third example, if I have the complex number -7 minus 4i, its complex conjugate would be -7 plus 4i. So we don't touch the real part of our complex number, and we change the sign of the imaginary part. That's how we come up with the complex conjugate. So we need to use the complex conjugate of our denominator. The complex conjugate of this denominator would then be 4 plus 6i, and we are going to multiply our denominator by its complex conjugate. What's going to go in our numerator here? Well, I don't want to change the value of this fraction, so if I can, it'd be really nice if I were to able just multiply the whole fraction by 1. And I can do that by putting another 4 plus 6i in the numerator. 4 plus 6i divided by 4 plus 6i, that's just 1. So I haven't really changed the value of this fraction. I'm multiplying it by 1, not a big deal. All right, so multiplying two fractions, we're going to multiply the two numerators and then multiply the two denominators. And this is like two sets of FOIL going on at once. So I'm going to move over here. We're going to FOIL the two numerators. 3 times 4 gives me 12. 3 times 6i gives me 18i. 5i times 4 gives me 20i. And 5i times 6i gives me positive 30i squared. That's our numerator. Now we're going to move to the denominator. 4 times 4 is 16. Outside we have 4 times 6i, that's positive 24i. Inside we have negative 6i and 4, which gives us negative 24i. And last we have negative 6i times positive 6i, which is negative 36i squared. So we have a lot of numbers going on here, a lot of i's, and we can clean this up quite a bit by combining like terms. I'm going to combine the 18i and the 20i in the numerator, and I will combine the positive 24i and negative 24i in my denominator. So this becomes 12 plus 38i plus 30i squared. My denominator is now 16 minus 36i squared. The 24i and the negative 24i canceled out, and that's not by accident, that's by design. That's why we specifically chose to multiply by the complex conjugate of our original denominator. And even more magic is about to happen. So I squared here, we remember that is the same thing as negative 1. I squared here is the same thing as negative 1. So let's substitute in negative 1s for those I squareds. We get 12 plus 38i plus 30 times negative 1. 16 minus 36 times negative 1. Continue to simplify. 12 and negative 30 give us negative 18 plus that 38i. In the denominator, this is going to be 16 plus 36, which gives us 52. Notice what just happened right now. We went from a complex, irrational denominator to a very real, rational denominator. We have successfully divided two complex numbers by rationalizing the denominator.